Okay, this is the back of the review. We are continuing with the directions that say solve the inequality, graph your answers on a number line, and write using interval notation. So these are rational inequalities. So we have that we have to look at, zeros in the numerator and the zeros in the denominator. So I'm going to start by factoring the numerator. So this will give me x and x. This is negative, so the signs are opposite. The numbers are going to be 3 and 4. 4 is going to have to be bigger. Always double check that you get this, get everything back like you had it. So there is my factored form. I'm going to find the zeros of the numerator. The zeros of the numerator give me the zeros of the function itself. So this is going to be a negative 4 and positive 3. And then the zeros of the denominator give me my vertical asymptotes. And in this case, it would be x equals 1. And remember, that is a line, so it is x equals 1. Then I need to draw my number line. And all three of these are going to go on my number line. I have a negative 4, positive 1, positive 3. Then I have to decide if my circles are opened or closed. Okay, so asymptotes always get open circles, so there's an open circle here. And then because this doesn't have an equal to, these are open as well. Then I've substituted in numbers from each little section here. So I'll start with a negative 5. Negative 5 in here gives me negative. Negative 5 in here gives me negative. The denominator would be negative. So overall, that's between negative 4 and 1. I can plug in 0. So this will give me positive, negative, negative. Overall, that's positive. 2 is going to give me positive, negative, positive. Overall, that's negative. 4 is going to give me positive, positive, positive. So overall, that is positive. All right, so then I have to shade. I want this to be greater than 0, which means it's going to be my positive. So here and here. So negative 4 to 1, open. And then 3 to. Remember, the interval and the number line are both part of your answer. All right, on number 11, I don't have 0 on one side, so I can move this over. I'm going to have 7 over x plus 3 minus 6 over x plus 2. So I can change this to plus a negative 6. And then I need a common denominator. Oh, that is less than or equal to 0. Need a common denominator, so I'm going to multiply this fraction by x plus 2 over x plus 2. This will be negative 6. I got to multiply this by x plus 3 over x plus 3. So then when I distribute up here, this is going to give me 7x plus 14, and then negative 6x minus 18, all over x plus 3 times x plus 2, less than or equal to 0. This 7x minus 6x is x, positive 14, negative 18, minus 4, over x plus 3 times x plus 2, less than or equal to 0. So this is what I'm actually using. So much going on, I'll write that out. The zeros of the function come from the numerator, so that's just a positive 4. Vertical aspect, I have 2 here. They're going to be x equals negative 2 and x equals negative 3. On my number line, so I have negative 3, negative 2, and 4. Then my vertical asymptotes give me open circles every time. The 0, since this is less than or equal to, this is going to give me a closed circle. So then I substitute numbers in. They're going over here. I'll start with negative 4. So it'd be negative in the numerator, and then negative, negative. Overall, that's negative. can do negative 2.5, which would give me negative, positive, negative. Between negative 2 and 4, I can pick 0, so it's going to be negative, positive, positive. Then if I use 5, it'll give me positive, positive, positive. So I want this to be less than or equal to 0, so these are my negatives. I'm going to go from negative infinity to negative 3. Never include my infinities. This is an open circle. Then from negative 2 to 4, this is an open circle. And this is closed, so I get a bracket. There are my intervals. All right, so the next part says to find all the zeros and find all zeros and given complete. Okay, and give. No matter. Doesn't make any sense there. Find all zeros and give the complete factorization of the function. Use the rational zero theorem, Descartes' rule of signs, and division when necessary. Simplify all irrational and complex solutions. So we have all these tools in our toolkit, and we got to make sure that we know when to use what and what makes sense. So I don't have to do all that if I can factor. So if you can factor it, and that'll keep you from having to try all these different things. So when I look at this, okay, so this is a 4th degree, but it is set up like a quadratic, so I can figure out if I can maybe factor this. So it might help you to have the factors of these written out, just because doing that is going to help you with this. So let's just start with that. So plus or minus 1, plus or minus 2. 72 is divisible by 3. Okay, so 3 goes into 7 twice with 1 left over. And so that would be 12. So that would be a 24 once we get there. 7 divisible by 4. Not divisible by 5. It is divisible by 6. Not divisible by 7. It is divisible by 8. It is divisible by 9. So 8 times 9 is 72. So then I've got to figure out 6. 6 times what is 72? Well, 6 goes into 7 once with 1 left over, so that would be a 12. And then 4 goes to 72. 4 goes to 7 once. And then giving me 8. Then 3 goes to 24. And 2 goes in, and then 72. Okay, so I don't necessarily need all of those, but you kind of have to think through to be able to factor this anyway, and so might as well have them written down in case I need them. And if I factor this, I got x squared here and x squared here. So I need two numbers that are going to multiply to give me 72. That's negative, so the signs are opposite. And then they're going to have to subtract to give me 14. Right? So if you look at which ones go, 8 and 9, I'm going to get a 14. 6 and 12, I'm going to get 14 out of that. That 4 and 18, those go together, right? I want this to be a positive 14, so this is plus 18 and minus 4. And then it's going to multiply back to give you what you need. So I can factor a little bit more. F of x is equal to, so right now I can't factor this anymore. This is squares, so x plus 2, x minus 2. So at this point, I can find my zeros. Okay, this is going to give me x equals 2, x equals negative 2. Here, x squared would be equal to negative 15. Be very careful. A lot of you had sign errors on this type of thing on the homework. Then I'm going to take the square of negative 18. Okay, so that negative is I would need to I square root of 2. Okay, because squared is 9 times 2 is 18. Make sure you get to 1. So here are my directions say to find all the zeros. Okay, I got that. Just state that here. It's going to give me plus or minus 2 and plus or minus 3i square root of 2. And it also says give the complete factorization. This is not the complete factorization. Factorization is using these. To be plus 2, x minus 2, x plus 3i square root of 2, and x minus 3i square root of 2. That is my complete factorization. These are my zeros. Okay. All right, so then the next one. Factor this one. Factor is not an option. Quadratic formula is not a quadratic. So I am going to need to find my zeros here. So my possibles would be all the factors of 6, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then all the factors of 6 over the factors of 5, so we already used the 1, basically all that's over 1. Then all of that over 5, so plus or minus 1/5, plus or minus 2/5, plus or minus 3/5, and plus or minus 6/5. Right. I can use Descartes' rule of signs. So I'm going to have, there's just one change here, so I'm going to have one positive real solution. And you can find the negatives if you think that would help you, figure out what's what. Or we can just go ahead and start trying some of these. So let's start with 1. Let's try 1 to go into, this would be 5. 6. 5, 17, 18, and 12. That does not help me. Negative 1, 1 into 5, 12, 1, negative 6. So this is 5, negative 5, 7, negative 7, negative 6, positive 6, 0. Okay, so that is good news. That means that this negative 1 works. Got f of x is equal to x plus 1 times, so don't forget this, some yellow leaving that, and then this gives me the rest of that, 5x squared plus 7x minus 6. So at this point, I've got that taken care of, that negative 1. So I can continue trying with this reduced version, or I can see if I can factor this. This one does factor. 5 times 6 is negative 30. So I need to multiply to give me negative 30 and combine to give me that 7x. So I can let this be x plus times 5x squared plus 10x minus 3x minus 6. Do my thing by give me x plus 1 minus 3, and then that would leave me with x plus 2. You might need to do an extra step in there for grouping, and that's fine. I'm just not going to do that. So this is my factored form, completely factored form, and then my zeros are going to be negative 2, negative 1, and 3/5. And there you go. Okay, 14. So looking at this one, I cannot factor this one by grouping either, which means I'm going to need my factors. This leading coefficient is 1. That's good. So the factors of 15 plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So I'll start with 1. This will be 1, negative 3, negative 13, 15. So 1, 1, negative 2, negative 2, negative 15, negative 15, 0. So that's good news. So f of x is equal to x minus 1 times x squared minus 2x minus then again, I could keep trying these, or I can try and factor this. This does factor, so we'll get x minus 1. Okay, this is negative, which means the signs are opposite. This is a negative 2, so that is going to be a positive 3 and a negative 5. There's my fully factored form. My zeros are negative 3, 1, and 5. And there you go. All right, so 15, once again, does not factor. So I need all my possibles, and leading coefficient is 1, so I need the factors of 36, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. Okay, if I use Descartes' rule of signs, let's see, my f of negative x would be negative x cubed plus 2x squared plus 17 x minus 36. So for my positives, that would be 1. For my negatives, that would be 1, 2, or 0. Okay, so doesn't necessarily help me straight away. I mean, I've got to start somewhere, so I can start with 1. Start with 1, and that's going into 1 to negative 17, negative 36. So it's 1, 1, 3, 3, negative 14, negative 14, negative 50. So that doesn't work. Negative 1. To 1 to negative 17, negative 36. Come on. Hang on, my board is not being cooperative here. I don't even know why I wanted to erase this, but now it won't respond. There we go. I think I just did the same thing, but all right, so this is 1, negative 1, 1, negative 1, negative 18, 18, negative 18. So either one of those work. So I'm going to move on to 2. So 2 is going to go into 1, 2, negative 17, negative 36. 1, 2, 4, 8, negative 9, negative 18. So that's going to be 40, negative 54. So that one doesn't work. So move on to negative 2. All right. And it's going to give me 1, 2, 7. Well, here, let me do a different color now, so they don't all blend together. So where am I? Negative 2. So 1, 2, negative 17, negative 36. 1, negative 2, 0, 0, negative 17, positive 34, negative 2. All right, so that doesn't work, so we'll move on to 3. 1, 2, negative 17, negative 36. So 1, 3, 5, 15, negative 2, negative 6, negative 42. All right, negative 3. 1, 2, negative 17, negative 36. It's going to give me 1, negative 3, negative 1, 3, negative 14. 3 times 14, that's going to be 30, 42, and that's going to give me 6. All right. 4. Come back to green. negative 36, and 1, 4, 6, 24, 7, 28, negative 8. All right, negative 4. 1, 2, negative 17, negative 36. 1, negative 4, negative 2, 8, negative 9, positive 36, 0. Oh, finally. Okay, so I knocked out my 2's and 3's. I had to go all the way to negative 4 there. This one works. So I have f of x is equal to x plus 4 times, then this leaves me with x squared minus 2x minus 9. All right, so I have a quadratic. See if I can factor. Well, my only factors of 9, 1 and 9, or 3 and 3, and neither one of those things are going to combine to give me this negative 2. Therefore, I cannot factor it, which means it doesn't do me any good to go through the rest of these. I know that this is my negative one, right? So I'm going to have 2 or 0, which means I'm going to have 2 of these and 1 positive one. So I still have a positive and a negative left, which we should know because that's opposite also. But since I can't factor it, that means I am stuck with quadratic formula. This side right here, x equals negative 4. I don't want to forget that. Okay. Let me see if I can get my board. So then I substitute this in. X equals negative b, so that's a positive 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c, which is a negative 9, all over 2 times a, which is 1. So that's equal to 2 plus or minus the square root. So this is going to be 4, and then negative and negatives will be positive. 4 times 9 is 36, so 4 plus 36 is going to give me 40 all over 2. Well, 40 is the same as 4 times 10, so I can take the square root of the 4 and bring that out as 2. That leaves me with the square root of 10. 10 is 2 times 5, nothing else gets to come out, all over 2. Then I can cancel each one of these out. They all become 1s. So I get x equals plus 1 plus or minus the square root of 10 over 1, which is just that right there. So here's my x. Here's my other one. Okay, and be careful here. Some of y'all were putting this plus or minus in a weird place. Clearly not a clue on how to reduce that, so don't be making things up. So my zeros are negative 4 and 1 plus or minus the square root of 10. And then my complete factorization, f of x equals x plus 4 times x minus the square root of 10 times x minus 1 minus the square root of 10. And there's my complete factorization. Okay, so on my key that I worked out originally, I made a mistake that actually ended up benefiting me. I kind of got lucky. I left off, when I wrote out these factors, for whatever reason, I left off 3 and 12. So when I did mine originally, I had to go through 1, I had to go through 2. I didn't go through 3 because it wasn't in my list, and I jumped to 4. So that meant I didn't have to do these 2 to get there, but that can work against you as well, because somebody did the same kind of thing on their homework and got stuck and was asking me questions. They left off a factor, I don't know what it was, let's just say it was 3. They left it off, and so they got past it, they didn't do it, and then they kept going, they couldn't find it, and that what they had left off was actually the correct answer. And so they were just doing all this extra work for absolutely no reason. So be very careful with that. I'm sure I just threw it too quickly and left it off originally. But so I did have to go through quite a few, but it's not that difficult, and you got to make sure that you're keeping up with your stuff. And I know there wasn't a ton of room on this one on the review, but I spaced everything out a whole lot more on the test so that you have room to, test things out or whatever. But when you get to these kinds of questions, you don't have to start by doing this if it can factor. I mean, I had to on this one, but on number 12, there was one similar to this on the quiz, and some of you started off doing this kind of process, which is not wrong, but it did cause some of you to get to a point where you didn't know what to do because of what factored out. Always try and factor. You're going to start to learn to love factoring so that you don't have to do all the guessing and thinking that goes along with it. Okay, so look over your returned homework and your returned quiz and go back through your review. Think about what the directions mean and when you use what, and make sure that you are ready for the test.